Okay, so hopefully you realize that these oranges, the grower, orange grower, is growing, is 9.50 for each box, and we want to know how much you could earn in 1 year from one tree. Well, on average, the tree produces anywhere between 1.3 boxes and 4 boxes. Um, so the lower end of that would be 1.3 times the, oh, it's so hard to write. Let me use this. The lower end of that would be 1.3 times 9.5 or 950. And the higher end of that would be if it produced 4 boxes. And then you'd have 4 times that, 9.5. So if we call the profits P, they have to be somewhere between these two values. So in other words, it has to be, or we would expect it to be greater than, we would expect P to be greater than 1.3 times 9.5, and we would expect P to be less than 4 times 9.5. And this might look a little bit weird if you haven't seen anything like this before. Because what we did here is we really took two inequalities and we put them together, and that is a compound inequality. So when you compound inequalities are really good for explaining a lot of different situations. Anything where you have a range of values you can express with a compound inequality. You can also express the opposite of that. So in this case, with our oranges, let's use this. We have an inequality now that represents this orange section of the line, but we could also write an inequality that is everything else. So we could also write an inequality that would be not this orange section. So we're going to see how to do that. First, we're just going to focus on working with the symbolic representations, and then later in the lesson, we'll look at more word problem kind of situations where you have to set up the inequalities yourself. Well, I guess you have to set up the inequalities right here, but it's not in context. Okay, so if you're given a description and you want to write a compound inequality that represents each phrase, and then graph the solutions, that means put them on a number line, what we're going to do is, let's take a look at this. All real numbers that are less than -3 or greater than or equal to 5. So a good way to think about this is let's write it in our simple inequalities first. If you can hear the chaos behind me, that's my kids upstairs being very musical. Okay, so all real numbers that are less than -3. So that would be like x less than -3, right? We could also write it the other way, -3 less than x. Oops, I wrote my sign the wrong way. I get a little bit distracted with this. Okay. X has to be smaller. So this, you could write that in either direction. We usually write it the top way. And then greater than or equal to 5. So all real numbers greater than or equal to 5. So here we have less than, let's switch up the colors. Greater than or equal to 5 would be x greater than or equal to 5. Okay. Which of course you could write the other way too, with the 5 and the x switched and the sign switched. So how do we write this as a compound inequality? Well, for situations where you have or, we are going to write it actually using the word or. So you can just write these two inequalities and then put the word or between them. So your answer here would be x less than -3 or x, I don't have a good way to do greater than or equal to, so I'm going to type it like that. Oh, I know what I'll do. I'll just draw the line in there. Greater than or equal to, oh, it's blue, 5. Now, if we want to graph this, we have to put these two inequalities on a number line. So our number line will have to include -3 and 5. So I am going to just go -5, and I'm going to go by 5s because it's really hard for me to write. If I was writing with a pencil, I would definitely write in all the numbers, but writing with this mouse is not the funnest, so I'm just going to minimize how much I have to write. Okay, so x less than -3. -3 would be about here. It's less than, not less than or equal to, so it's open circle, and my arrow points to the left. X greater than 5, greater than or equal to 5. That means filled in circle. I'll do my best to fill in a circle, and we're going bigger than that. So you can see here, we are talking about all of the numbers on the number line that are outside of these 2 points. So every real number except the ones in between these 2 dots. That's what my arrows here are telling me. Let's look at another example. This is one that uses and. We see and. Here we saw or. So there's different ways. If you see or, you write it like this. If you see and, we're actually going to write the compound inequality without any words. So let's take a look at how we do that. A time a cake must bake is between 25 and 30 minutes inclusive. We'll talk about this word in a second. Okay, between 25 and 30. So my time, I'll use the letter T, doesn't really matter what letter you use, is between 25 and 30. So my time is greater than 25. And I'm going to write it that way because then I can write on this side less than 30. And that's the compound inequality where we've taken, there's only one T, there's 2 inequalities baked into one thing here. You've got T is bigger than 25, and you've got T is smaller than 30, and they're just kind of written together. They're attached. Now, we've got this word over here, inclusive, and what the word inclusive means is that we want this to include the values 25 and 30. So we want this to be, both of these inequalities to be an or equal to. And then we finally have to put that in a number line. So we go number line. It's so straight. Just kidding. It looks like a smile. I guess it could be worse. All right, so I'm just going to put 25 and then 30. And over here would be like 35, 40, and down here would be 20 and 15. And I have filled in dots in both spots. Filled in dot, and I have T being bigger than 25 and less than 30. So what we end up with is just this section, and it can be hard to shade on the number line, so we're just kind of using this style where we draw the arrows above the line. In this case, there are no arrows. We're just connecting these 2 dots to show that this is the area in here that we are. This is the area in here where the cake times could possibly be. All right, so try a couple of those, see how it goes, and then we'll look at doing some solving with these